The Big Bang. After Lemaitre suggested that the redshift of galaxies was due to the expansion of the universe, in 1931 he suggested that in the past the universe was smaller and at some point all the mass of the universe was concentrated into a single point when time and space were created. This creation of the universe from an expansion from a single point was later called the Big Bang. In 1964, two physicists, Arno Penzias and Robert Wilson, working at Bell Labs, were using a telecommunications antenna to study the emission produced by the Earth's atmosphere to study possible sources of interference for satellite communication systems. They were surprised to find a uniform background of noise which would not go away. The antenna was full of pigeon droppings and they thought the noise was due it. The antenna was cleaned, but the noise remained. They noticed that the noise did not depend on the time of the day, so it was not an atmospheric phenomenon and not associated from sources from our galaxy because it was evenly distributed on the sky. Close to them in Princeton, a group of astrophysicists were trying to get the same results that Penzias and Wilson accidentally found. Penzias and Wilson published their results, and the physicists from Princeton explained what the results meant. The uniform noise came from a prediction of the theory that Lemaitre proposed that the universe started from a single point. Stars burn hydrogen and synthesize helium and other elements. This is similar with the way the hydrogen bomb works. Spectroscopic studies show that 25% of baryonic, ordinary matter in the universe is helium, 73% hydrogen that did not convert during fusion, and the rest traces of heavier elements like deuterium and lithium. The percentage of helium-4 in the universe is too high to be explained by the production of helium in stars. In the 1940s, a model was proposed where hydrogen fusion occurred throughout the whole universe when it was really young. According to the model, the hydrogen fusion reactions during the early stages of the universe, nucleosynthesis, predicted a radiation background with a present-day temperature of 5 degrees Kelvin. This was a background radiation that the people from Princeton were trying to discover, and Penzias and Wilson accidentally did about 15 years later. Penzias and Wilson later shared the Nobel Prize in Physics for the discovery. The Friedman models, with the assumption of hydrogen reactions with temperature in the universe of more than 1 billion degrees and using models from hydrogen fusion, predict the right amount of hydrogen and helium if there was nucleosynthesis during the first seconds after the creation of the universe. The first two observational evidence that the Big Bang happened was the uniform background radiation, cosmic microwave background, CMB radiation, and the observational results for the hydrogen reactions throughout the universe during its creation, nucleosynthesis. The Big Bang later was supported overwhelmingly by other observational evidence such as galactic and stellar evolution. So the universe expands, and it started from a single point when time and space were created.